Hi everyone. So I am going to demonstrate how I would use Desmos to introduce the ellipse to my students. I am using this activity that I made in Desmos. So here I go. So class, remember we have covered the circle already. Remember that the circle centered at the origin is the graph of this equation. The r is a positive number and it's the radius. As a specific example, here we have the circle centered at the origin of radius 2. So this is the graph of this equation, as you can see. Now, with this equation, notice that if we were to divide both sides by r squared, this equation would become this equation. Okay, so what is this telling us? The graph of this equation is the circle centered at the origin of radius r. Again, r is positive, so in particular, r squared can't be 0, so it makes sense to do this. Now here, we have x squared over 9 plus y squared over 9 equal to 1. So what would that be the graph of? Well, if you compare the two equations, we can see that r squared in this case would be 9. So, let's type it in. If r squared equals 9, then r would be, as we have seen, the square root of 9, which is 3. So this would be the circle centered at the origin of radius 3. Okay, so that's what this here would be the graph of. The circle centered at the origin of radius 3. Okay, let's move on. Now, we're going to look at this equation. Here, the denominators are a squared under x squared and b squared under y squared. We are assuming that a squared is not 0, so in particular it's positive, and b squared is not 0. So in particular, b squared is positive. So now we have a squared and b squared here, okay? So these denominators don't have to be the same. On the previous slide, here the denominators both were the same, as you can see. That's not the case here. So, to see what's happening, we're going to fix a equals 1 on the next screen. We're going to let b vary. Now we're going to let b vary and b be positive, okay? So we can see what's going on. So let's do that. So we're going to take a to be 1. Now b is positive. Here's our graph, as you can see. So let's vary. So it's not a circle anymore, right? When b was 1, we had what we call the unit circle. That's the circle, if we zoom in, centered at the origin of radius 1. But now if we let b vary, right, we're taking that circle and stretching it up and down, vertically that is. When b is 2, we get this. When b is 3, see if I can get it, there we go. Let me zoom out a bit. I'm using the mouse to zoom out. We can also use these. And if b is 4, okay. Notice also that when b is 4, the points of intersection are 0, 4. Down here, it's 0, -4. Now watch those points. See how they're changing? When b is 3, what is this point? 0, 3, 0, -3. So that's what happens when b varies and a is held fixed. This is going to be stretched vertically, the graph that is. So we have an ellipse, like so. So what happened here? Well, again, we stretched the graph vertically. What were the points of intersection? Well, remember, we said already that when b is 3, this point is 0, 3, 0, -3. Just before, when b was 4, we got 0, 4, 0, -4, when b is 4. Well, it looks like then the points of intersection are going to be 0, b, and 0, -b. That's what the points of intersection are. Right? When b was 3, these points were 0, 3, 0, -3. That was on the previous slide. When b was 4, we got 0, 4, and 0, -4. Okay, and that's when a is held fixed. Right? Again, also the points of intersection, they're on the y-axis. b squared is under y squared. Okay, that's good. Let's keep going. So now we're going to, A and B are going to interchange roles, so to say. We're going to let B be held fixed at 1. A, we're going to let vary. Just like before, A is going to be positive, and we're going to let it vary. So, here we go. So now, that's B. B is held fixed at 1. We're going to let A vary. What's going to happen? Well, now it's still being stretched out. Again, when A was 1, right? The graph was the unit circle like before, if we zoom in. See? But now we're going to let A vary. As A gets bigger, we're stretching the graph, right? Horizontally. A started at 1, right? As you can see, if A is less than 1, the graph gets pushed in, compressed horizontally. So it's moving basically in the horizontal direction. Now notice here, when A is 3, those points of intersection, hopefully you can see from the graph, we have 0, -3, 0, and this is 3, 0. Now, watching those points, what happens when A is 4? There we go. You can see from the graph that it's -4, 0, and 4, 0. When I bring it down to 2, as you can see, the points are, let me see if I can get them, -2, 0, and 2, 0. So it seems like there's something going on with the A and these points of intersection. Namely, here, it seems that the points of intersection are of the form A, 0, and -A, 0, as we saw in the graph. Okay, so that's good. So it looks like this is a graph. The graph of this is an ellipse. And the points of intersection involve these A and B. Let's write that down. So what do we know about the points of intersection? Well, the points of intersection are A, 0. Let me use the math type to make it look nicer. We have A, 0, -A, 0, 0, B, and 0, -B. Now, it is centered at the origin. So having these points of intersection, we can actually make a rough sketch of the ellipse. So let's practice that now. Okay? So now I'm going to close this and we're going to do some examples.